Warning: tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're back working on the R300. Got the bottom off of it, as you can see, and I've dove in to just the power supply design in this amplifier, which I feel is the root of most of the problems that I'm hearing about from people online. And I'm really thinking that this underfiltration is probably the noise that we saw on the audio analyzer suite. So I'm looking for a simple solution that disturbs as little of the existing amplifier as possible, that will increase the reliability, and hopefully that's where this noise that we're seeing in testing came from. So let's get busy seeing what's here. Okay, so let's look here at what they've done with this power supply. This is the ground. These are the two high voltage AC terminals. And the ground is also the center tap. Okay? So first, it's got a 10 ohm resistor that comes over here to this terminal, which is just acting as a tag strip or a tag point. Now, not all of these have this delay board in them. And this is not a soft start. This is just a delay board. A soft start would slowly bring up the B+. That's not what this does. This waits until the heaters are heated up, and then it applies the high voltage AC with a click to the rectifier tubes. So anyway, this is our high voltage AC on one side. It comes over here to this delay board, comes off on this wire right here, and it comes over to this terminal here on the rectifier tube, which is one of the plates, and then this jumper wire comes over here to the other plate. Now, it's important to understand that only 4 of the terminals on these rectifiers are used. Let me zoom in here and see if I can get a little better shot of this. Okay, so again, this is where the high voltage AC comes in. It goes to this plate, and then it jumps across to this other plate. So they have the two sides of the dual diode rectifier in parallel. So high voltage AC jumps across to the other plate. This is one of the 5 volt heaters, which is pin 2. Then pin 8 is the other heater, and it's where the high voltage DC comes off the rectifier. So then they have a 10 ohm resistor that comes up to this unused pin. And now here's the baffling thing to me. Then it goes through a big silicone diode. So we have a rectifier with 2 diodes that are in parallel, and then the output of them goes through a resistor and then goes through another silicone diode. So really, you could put a jumper wire from this pin to this pin and just leave the tubes out, and you'd still have DC. I'm honestly not sure what the rectifier tube's even doing. I mean, it's in the amp and the voltage is going through it, but then it's going through a solid state diode. So the rectifier tube is on the other side of a silicone diode. So looking at the way this is wired, I really don't see how this rectifier tube's going to have any impact on the sound, because it's going through a solid state rectifier or diode after the tube. So anyway, then it goes on this wire here, and it jumps across to the output of this other diode that's wired up the same way. It starts here, goes through this 10 ohm resistor, goes to this point right here, which is just a tie point, comes up here to this delay board, and then it runs over here to the plate This wire here jumps it over to the other plate. And then heaters here. And this is the cathode of the rectifier tube. Goes through this 10 ohm resistor to this unused pin. This being used as a tag point. And then goes through this diode and outputs. So the two outputs of these tubes are tied together. And then it goes through this red wire here, which then comes over here to this printed circuit board. And really, guys, this is not a point-to-point wired amp. I mean, some of it is, like the front end tubes are somewhat point-to-point wired, but they're still using printed circuit boards. And the signal in a lot of the wiring is going through circuit board traces. But anyway, I digress. Let's stay focused on this power supply. So this is the output from the rectifier tubes. It's tied to this wire here that goes up to this choke. And then it comes out of the choke to this point. Then this wire here is tied to it that comes over to, let me zoom out so we can kind of see what's going on maybe a little better. So this was the output of the choke, and it goes up to this giant 330 UF 500 volt cap. Now it looks like, without pulling this board out, which I would have to unsolder a bunch of wires to get to it, this is the first cap that the rectifier tube sees. And it's 100 UF 450 volt. So then after the choke, it goes to a 500 volt cap, which doesn't make sense. If anything, you'd want the higher voltage one to be the first one in the chain. And obviously I'm going to have to measure the voltages, but this could probably easily be a 450 volt cap and it wouldn't be a problem. But anyway, we'll look at that when we check the voltages and when it's powering up and all that kind of stuff. And then it goes through some dropping resistors here, and it looks like then it pulls the voltage way over here in this corner to go to the output transformer. So there's a trace going across the board over here, which seems kind of weird. I don't know why they wouldn't just hook that wire up here. But anyway, got a lot of voltage and stuff going through this printed circuit board, and this set of capacitors here and these diodes are part of the bias circuit. So I'm trying to figure out what is the simplest way to resolve this, and let me show you on a schematic I drew up of this part of the amplifier, and then what I think needs to be done to resolve this issue with it not having a soft start and it popping rectifier tubes like I've seen other people report online, and the reason they put this board in to try to alleviate that from happening. So let's look at the schematic. Okay, so here is what I drew up from inspecting the amplifier. This is my hand drawn up schematic, just reverse engineering following what I showed you in the previous segment. So here is the high voltage winding right here. This is the 5 volt for one rectifier tube. Here's the 5 volt for the other rectifier tube. We have a 10 ohm resistor. The plates of these 274B tubes are tied together. So rather than acting as a dual diode, it's acting as a single diode with the two diodes tied together in parallel. This is the cathode. You can see it's a directly heated tube. so it comes up online really quickly as far as the voltage. This is the high voltage DC that comes out of the tube rectifier, goes through another 10 ohm resistor, and then, oddly enough, 2 silicone diodes. And this other tube does the same thing, pulls the high voltage DC off of pin 8, comes up, goes through a 10 ohm resistor, through a silicone diode, and then up here to the DC rail of the power supply. So you can see that if we tied this to that, just pull these tubes out, these diodes would do the rectification and we'd still have DC here. And whatever kind of sonic joy people think they're hearing from these rectifier tubes in here, I feel it's going to get negated by going through silicone diodes before it goes to the rest of the power supply. So the other issue we have here is this first capacitor is a 100 UF, which for a regular production 274 rectifier tubes, this is supposed to be a max of 4 UF. So it's 25 times what the data sheet says is the maximum. Now there are some that allow up to, I think, a 47 UF, but this is still twice of what that is. And I've done a video, I think, about why this is important, and maybe this will be a good series to insert that again about why you don't want a giant capacitor here and how it's not only hard on the inrush current, it's hard on the rectifier tube, period, even just during general operation. So maybe in the next video I'll explain all that. So then it has a choke that's labeled a 4 Henry choke, but I've measured these Willsenton chokes before, and they actually measure at 1.5 Henrys. It's got 35 ohm DCR, which isn't much, to be putting a 330 UF cap after that. And then this is going out to the power supply. And if I recall in the data sheet that the total of these two capacitors is not supposed to exceed 50 UF. And we've got 430. So I'm not shocked that they're having issues with these tubes arcing on startup. The other thing that I didn't draw into this, because not all of these amps have this, is where I've got the mouse right here between the transformer and this 10 ohm resistor is where that delay start circuit is interrupting. So it's basically a relay. There'll be one here and one here that blocks this high voltage AC from getting to the rectifier tube until these heaters have come up. But then once this clicks on and this is heated up, it's just basically turning on the light switch for the voltage to blast through all of this, you know, the inrush current filling up these two caps and then blasted through to the 300B tube, which I don't think is good for a tube amplifier. So here's what I'm suggesting or going to try on this amplifier to try to clean up the power supply. And same transformer, probably going to leave this 10 ohm resistor in place, leave these tied together, but this time we're using a 5AR4. You can see this is an indirectly heated tube, so that this tube doesn't conduct until this heater has 10 seconds or so to warm up the cathode to the point that it can start conducting. And I'll show you the difference when we're working on the amp and how slowly the voltage ramps up using these indirectly heated tubes. So we're going to put a pair of 5AR4s in. The outputs are going to get tied together up here at the rail. We're not going to have a resistor on the output. We're not going to have a diode on the output. We're going to use these rectifier tubes for what they're supposed to be doing, which is rectifying the AC. So we're going to add a 330 UF cap for the first cap. Then we're going to put a 2 Henry 56 ohm DCR choke. And then it's going to connect to the rest of the existing power supply with this 100 UF cap, 1.5 Henry 35 DCR choke, and then the 330 UF cap going out to the rest of the power supply. And the key here is this first capacitor is below the rated max, which makes it easy on these rectifier tubes to do their job. And then we're not going to need that delayed start board because this type of tube has a slow voltage ramp up, so we don't need all that electronics inside the amp. So let me jump over and show you how I'm physically going to install these parts. Okay, so having seen the schematic and after seeing what I think needs to be done to clean up the power supply using 2 LC filtering networks in series, there's not a whole lot of room in here to work to put another choke in. And this choke here looks like the same choke that was in the R8. The DC resistance measures exactly the same. It looks identical. It's got the same 180 milliamp 4 Henry label on it, but when I measured the inductance of it, it was only 1.5 Henrys, which really isn't enough choke to clean up a power supply for a single-ended amp. The R8 can get away with it because it's push-pull, and push-pull amps have self-canceling, given that they do one side and then the other of the AC and reassemble it in the transformer, that cancels out hum in a way that a single-ended amp can't. And I don't think these 274B tubes are doing this amp any favors other than looking pretty. And so I think we're going to go with some 5AR4 rectifiers. And one of the things that we can do that I'm going to have to play with a little bit, they've got some little extra stands here. I'm not sure if I can get rid of these or not. I may not be able to. We may have to just leave the tubes kind of sunk down in the amp, but it would be nice if I could flush mount this so that they sat at the same height as the other 8-pin tubes. I know they sunk it down like this to use those giant bottle rectifiers. But anyway, that's for some later mods. The main thing I need to work on is where are we going to put these parts? And I think that if I pull this delay board out, which if we use 5AR4 rectifier tubes, we're not going to need, because they automatically, just the way they're designed as an indirectly heated rectifier, they are slow start, like in a legit way where the voltage actually comes up slow. And I think I want to use this 157R Hammond choke. It's a 2 Henry, 200 milliamp. It's going to be a challenge to make up a bracket, but I think it will fit right where this delay board was once we pull it out. And there's just enough room between these terminals on the transformer and the side of this board. So if we can get the choke bolted down right here, I should be able to put a tag strip on this screw and then have a either a 22 or a 33 UF first cap, probably a 500 volt one, that'll sit right here with this the ground, and then run the ground over here to this point right here. And then we can run one of the choke leads over here to this cap and have this, DC power lead come over here to this tag strip and this capacitor. Then we can take the other side of the choke and just run it over here to this board. And we don't have to mess with any of this other wiring. And I really think that's probably the simplest way to do this, because I want to do this in a way that's easy for viewers to replicate. And I don't want this to be like the R8, where we're just ripping out tons of wiring just to get it to a workable, reliable state. And I think the main problem is it needs a second choke and it needs a smaller first cap. And having this 100 UF cap after the first choke isn't a problem. It's only a problem if this is the first cap that the rectifier tube sees. Even with a 5U4 GB, we're still going way past the recommended maximum capacitance for the first capacitor. And so, that's what's going on with this thing. I saw the same problem with the New Sound 6P1, and I've seen it in some other made in China amps where they put the first cap after the rectifier tube, just this huge value. And then I know that they're trying to protect the rectifier tube with these 10 ohm resistors, and then putting this silicone diode on the output of the rectifier tube, trying to keep them from blowing up, because you shouldn't need a rectifier tube and a diode in series in a tube amp power supply. And if we're going to bother having a rectifier tube, we should be using just the rectifier tube and not a silicone diode. Honestly, guys, the easiest solution is probably going to be to pop a couple of silicone rectifier replacement things in these sockets and just not worry about having a tube rectifier. It'll make the power transformer run cooler, because these are 3 amp each rectifier tubes, which aren't needed because there's silicone diodes in here. I know I've said that a half dozen times, but it's just baffling to me why they would do that. The other thing that seems odd is they have these really thin wires coming up here to the heaters, and this is some of the highest amperage draw in the whole amplifier, is heating up these 2 rectifier tubes that have 3 amp filaments each. And so that's another reason to go with a 5AR4, because it's got a 1.9 amp heater, and or pop a couple of silicon rectifier replacements in here, and then you don't have to worry about any of this other stuff. The only problem with that, though, is we still don't have enough filtration. And so probably the best solution, if you're going to go inside it, is to add this choke. But for reliability, probably the simplest thing is just replace the rectifiers with some replacements that are solid state. And I'll show you the ones I like that have built-in thermistors, which also help with a slow start. So that's where we're at. And this looks like a good place to wrap up this video and try to figure this thing out. Well, I hope what I just showed you makes some sense, and I'm hoping that this isn't going to be a really difficult retrofit process. So I think removing this delay board is going to give us just enough room to add the choke in here, and it might be a little tricky fabricating up a bracket. And again, I know that sort of thing is what really frustrates a lot of people, especially folks that don't have a lot of experience working with their hands or doing fabrication work. So I'm going to try to come up with something that's fairly simple to make that uses some existing screws, and it might not be the prettiest thing on the planet, but definitely just want to make it where it's secure, and then there's room to run the wires and put the other parts in there. So I think just a little 2, maybe 3 terminal tag strip here, bolting that choke in, adding a couple of parts, and going to the 5AR4 rectifiers are going to fix it. And again, I feel like if there's something about these 274 tubes that sound great, that magic is going to be at least partially negated by these diodes having to be in series with them to keep them from arcing or going bad, and that naked 5AR4s with no sand in this path is going to sound better. So let me get working on this. Probably going to do this initial kind of fab work off camera as I'm trying to scratch my head and figure out what I'm going to do. But I definitely will come back in a video and show you what I did and then show you the results. So hope you're enjoying this content. If you are, please subscribe to the channel. Please like the video. Thank you again, Patreon folks, and also you folks that make donations to my website, and for generous viewers that drop ship stuff like this to me and trust me with their products while I work on them before I send them back. So anyway, until the next episode, have a nice day.